welcome to our
Hello.
launch event. Really good to see everyone. I might just get us started because I know we have some amazing talks to cover today. And I just want to say this is super special because it's the beginning of our 6-week expedition. So the reason why we're doing these lightning talks today is to kind of celebrate projects that we did last expedition. And also to just serve as like a moment to recognize all the captains and all their projects and everything that's kicking off. So let's see. So maybe I'll briefly introduce myself. So I know some of you are new to our community and are joining, especially because of Expedition. So I lead Cohere for AI. A lot of our work is how do we expand the spaces for breakthroughs. We do frontier AI research, but this is part of our effort to really support what ideas our really open science community has. And what you'll see over the next hour from the talks we'll kind of profile is just the incredible work that came out of last year. And hopefully it will serve as a North Star for your own expedition projects. And let's see. So am I driving the slides, or Britannia, are you?
Sarah, sorry, I'll just set you up as a co-presenter.
Okay, amazing. Thank you. But thank you to whoever who anticipated that it was a new slide. Okay, perfect. And it looks like, Marcia, you're going to take on the Expedition Aya retrospective. Fantastic. Okay, so without further ado, I'll just pass it over to Marcia to think about the expedition. Today we're going to have a series of amazing talks. So we're going to have talks which are not just about the projects which happened last year. It's also about like some of the projects which maybe you'll use as resources. So if you're doing Aya Vision multimodal projects, we have research which is Oliver will present on Aya Vision evaluation data. Shivalika is going to present on Global MMLU, which was an open science project that spanned our community, many different cross-institutional collaborations, and Sara. And then before that, we have these 3 fantastic spotlight talks, which are on projects from last year. So we have Emma Wardbench. I see Shrishti's here. A few other people from that project are here. The Maya multimodal. So Karthik, fantastic. This was a very special project, and we're going to build on it again this year. And then, of course, Christopher, nice to see you. So I think this will be a very nice spotlight talk. So without further ado, let me pass to Marcia and then go for it. And then we can kick off the lightning talks. The lightning talks are fun. We have 5 minutes for each. And so it'll be a nice chance for each talk to kind of profile what they're working on. And I will keep time, but I don't think I'll have to. But let's enjoy this and celebrate each speaker as they come on. Marcia, go over to you.
Yeah, thanks. Hi, everyone. I'm Marzia. I'm a research scientist at Cohere for AI, and I have been part of the Aya from day one, just like a year of building Aya dataset, Aya models, and then continuing to Aya 23, and then last year, Aya Expedition, the first edition that we launched. And I thought today, so we are going to hear about, as Sarah said, about some of the projects from last year. So I don't want to talk too much about the details of that, but I thought it would be nice to just put the spotlight on them and also share some of the learnings about how a good collaboration can work out from that expedition, and also our experience for you who are joining us in the 2nd edition of this initiative. So last year we had more than 25 projects in the end, just getting through the 6 weeks of intense working together, every week presenting, getting feedback, working on towards their goals, which was really impressive. And some of them, they continue to collaborate. Even today, we have teams from last year joining this year's expedition still. And it involved more than 100 researchers from 29 countries. At that time, the focus was on multilingual projects. We had Aya 23, so no multimodal vision models, and there was diversity of topics in the projects that we saw that came from people and their passion about each of these topics. So it went from building tools like chatbots addressing like a real issue like climate change and how to communicate effectively across languages, all the way to just building multilingual data sets for evaluation of reward models, to maybe like focusing on linguistic quality of language models. So we will hear from all of these projects today. And then we also had the Maya project on, that was the most promising award. And I think they held up their, like that title really with really an excellent work that they did in continuation after the expedition. And the language effect project, which Christoph will talk more about that this year. But I do want to quickly, just as a quick note about, now that you are thinking about finalizing the scope documents for your projects in this expedition, I like to remind you to just think about this, what you want to achieve more concretely in each of these projects. So with more details, thinking about what questions you are trying to answer, what you should be comparing to, what are the baselines, what do you want to evaluate on, the details of the experiments. So the more detailed you are at this point in your scope document, the higher chance of success, because 6 weeks go by really quickly. So just jump in your scope docs, and you can always also tag us for questions or feedback. And then speaking of feedback, this is really important because you are building teams. Most of you, I think, people you haven't met before. So, and you are working with us as mentors. So it's really important to communicate effectively to get the best outcome and the best feedback from us. So whenever you ask questions, try to also have like a concise summary about the context, or link to like papers or codes or slides. So in the next 6 weeks, we will jump into the projects to help you out, but you can also provide really like good context for each of your questions to us. And also really ask specific questions. Just feel free to just really ask about, is this really like this methodology sound? Are we presenting the results clearly? So the more specific you are with your questions, the better we can help you. And also be open to criticism from both us and your teammates. We are here, all of us, to build together and grow our research agenda. And yeah, with that, this is really the first step for many of you towards building your future research network. So really also have fun, try to connect to people. And yeah, I look forward to see what everyone does in this expedition. With that, I think I pass it to Srishti.
Thanks, Marcia. Really nice overview. Yeah, so hello, everyone. I am Srishti, and I'm currently a research scholar at Cohere for AI. And what I'm going to be talking about today is our project from the last expedition, and it's called M Reward Bench. And before I start digging into what the project actually is, I would mention that we were able to publish this one as a paper. I mean, currently it's on archive. We hope to get it accepted somewhere, but otherwise it is really out there for you all to read. So what exactly we did as part of this project is that we worked with reward models in an area that was largely underexplored, which is for non-English data. So like people who are not familiar with what reward models actually are, it's totally okay. I'm going to explain it in very simple terms. Okay, not able to go to the next slide. Not sure why that's happening. No worries, I'm just going to speak and wait for it to move. Yeah, so what happens is that, so it's like even if one is not familiar with RLHF, it's fine. What reward models actually are is that they act as an oracle. So it's like they act as the source of ground truth in helping us decide which out of two responses corresponding to a particular prompt is the preferred one. And when I say the preferred one, I mean preferred one for humans. So that's what reward models actually are. And given that they do play a very crucial role in the whole model training pipeline, I am not sure what's going on with the slides.
Yeah,
They're just
who is
moving.
owning the slides? I just want to, it sounds like we have multiple owners. Can we just make Shrishti the owner and not have anyone move it? If you have control of the slides, don't move it. Okay, amazing.
Yeah,
Just
I
pulling them back up. Sorry about this, everyone.
We have over exuberant co-presenters. Okay.
yeah, no worries. I think
You have access to the slides, right? Why don't you just put them up right now? Or I can, actually. It's okay. Whichever is easier. Here we go. Amazing. Okay, Shrishti, why don't you present away and then we can have, we can figure out what we do with the next one.
Yeah, sure. Can you go to the second slide, please? Not this one. Yeah, I think it just, yeah, this is fine. Yeah. So yeah, as I was telling, what reward models actually are is that they act as the oracle in deciding which of the two responses corresponding to a particular prompt would be the preferred one according to a human. And when I say that, it should be very clear that they play a really, really important role in just deciding which one is the preferred response, and that directly is the signal that we feed to our models, and eventually our models are also going to emit those responses. I mean, not exactly those responses, but I hope you're able to get an idea of what I'm trying to say while we prompt our final models. And that is why we want our reward models to be really, really good at what they do. So up until our project, major research as far as evaluating reward models for their quality is concerned was focused on English only data. What we did is that we took one step forward and then we evaluated reward models on non-English data. And to be very specific, we covered a suite of 23 languages. But before we do that, we also need to have that multilingual data, in 23 languages. So we also built that data as part of this project. That was also one of our major contributions. So what we did is that we first built our multilingual data set covering 4 total categories in 23 languages. And then we evaluated a suite of 20 plus reward models on this data set. And while we consider different languages, we made sure that we are covering a diverse variety of languages. And so as a result of this project, we were able to uncover many interesting insights into how reward models differ as far as their performance on English versus non-English data is considered. And this also motivates the research community to build better reward models that are not just focused on English, but also on all of the languages. So that, the ultimate goal is that we are able to build models, build LLMs that don't just serve the English-speaking population, but serve the world population as a whole. So yeah, that was what our project was about. And now I want to focus a little bit on how it went for us, how we came together, and how we made sure we make our project a success. So as you all must already know, there is a Google Sheet out there. There are a lot of, project proposals out there in that sheet. So I would really encourage everyone to just actively go and interact with whatever project interests you. Just go out there, talk about it, share relevant papers, share whatever ideas you have, and then, just start building. So this happened for me as well. I saw this project, I think someone, and I think it is Sara, had put this project already in the sheet. So I just noticed it. I was like, okay, this is what I really want to work on. So I started a thread, I started leading discussions, and as a result of that, I also was the captain of this project. So yeah, that's how it started. But one crucial piece of advice here would be to start figuring out your team as soon as possible and then finalize it also as soon as possible. Because I mean, as much as it is about your research idea, it's really, really also about the research team that you work with. If you've got a great, coordination and communication with your team, it's very, very probable that your project is going to be a success. So it's really important to decide your team as quickly as possible, and also hence run the first set of experiments as quickly as possible, and not really fall into that trap of brainstorming and then coming back, brainstorming then coming back. Just start with whatever experiments you think are sensible for your project. And yeah, I think for the captains, my one little piece of advice would also be to allocate work wisely, so that every team member is getting the work that they are able to do, and no single person is overloaded with a lot of work. So yeah, that's just one thing. And overall, I think just make sure you have fun. I had a lot of fun as part of this project. I was also like very lucky to have found the best team. We were also thinking of doing one more project in this expedition, but unfortunately I am busy with some other things, so I couldn't do it. But yeah, I think like this is really a very wonderful opportunity to connect with other research people, to connect with other researchers, find your future collaborators as well. So yeah, it's really important to have fun, and yeah, I wish all the very best to everyone.
That was amazing. Such a great. And I love the advice at the end. I think this is also a really good exercise in like how research collaborations work. And the truth is the best breakthroughs happen when people are super excited about the idea, but also willing to just get started. I think I think in some ways research is a very iterative process. And what I would recommend is figure out the first experiment, the experiment that will give you the first signal about whether an idea succeeds or fails. Start with that. Don't add complexity until you're through that first one. And I think that's what Srishti is saying, is that you found a great team who was willing to just get started. And that's super important. So fantastic presentation. So am I excellent? Madeline's controlling the slides. Perfect. Karthik, super excited for you to now present on Maya. So I'll pass it to you.
Yeah, sure. Thank you. Hi, everyone. So I'm Karthik. I'm also currently working on Maya still. So I'm a researcher. Also, I'm a machine learning engineer at a stealth startup. So I'll go briefly about Maya, how we started, what was our journey like, and where we ended up, and what's our next mission is like. Next slide, please. I can control it. Yeah. So the beginning of the Maya journey, welcome you all. So in May 2024, at Cohere for AI community, the idea initially was sparked by Nahid during No Bad Ideas thread. So how could we actually transform Aya, which is a multilingual language model with vision capabilities, so into a multimodal? So then we actually began drafting a project scope document, and then I was the next person who joined on that document, and then more people started along to join that scope of the document within the C4AI community. We have no idea about the IA expansion. We don't know about the IA server at that time. So this was all happening within the C4AI community, no bad ideas. So our vision then was to actually analyze what are the open source architectures that are available, how we can actually extend beyond just visual capabilities, because we have a long-term goal, like not just vision, but to enable all the modalities that are possible with language model. Yeah, so this ambition led to the birth of Maya. M is multimodal, and Aya is the Aya as the language model. And our inaugural expedition with Aya started when Sara Hooker, Shivalika, Madeline, all of them told, so there is this expedition Aya coming up, and we would like you all, because it was our place for the very first time where we can actually form a team. Until then, we didn't have a team, but we know we have few members who are actually interested and well aligned with the scope of the document that we had that day. And then that was our journey where we started, and the incredible collaboration of a strong team whose dedication continues to drive our progress even today. So that was it. So at that time, our goal for Maya was to bridge the gap in multilingual vision language models. Our initial research focused on identifying open source vision architectures, as I mentioned, so leading us to choose Lava 1.5 as the foundation. because it's the most straightforward approach to build vision modality, while ensuring full multilingual support by integrating IR238B as the language model and SIGLIP as the vision encoder. So the next challenge was implementing this multilingual architecture effectively. So that was the challenge. But at the same time, on the dataset side, since there is no multilingual pre-training dataset existed, when I say pre-training dataset, it is of image text pairs for vision language models. And there is no multilingual dataset that is open source and available for that. So we had to create our own. While also there is instruction tuning dataset available by Palo, it is of 150K samples per language. So our scope is clear on the model side. So we have this Lava 1.5 architecture. There is some code available out there. We need to use that. And then we need to change the language model to IA and should make that work. And SIGLIP as the vision coder. And SIGLIP also, it's not an English vision encoder, it's a multilingual vision encoder. So that's the part of it. And on the data set, we need to figure out, because we only have, our starting point is only the Lava pre-trained data set, which is in English. So then we built our own translation factory. So this why I call this as a translation factory, because within this translation pipeline, we had like 3 stages of machine translation. So initially we identified, so within the image text pairs, there are some instructions and there are captions, but the instructions are only 11 unique instructions, but the captions change as images change. So we used human annotation to actually translate the 11 unique instructions. And then we created a prompt engineering pipeline. So we use this zero shot, few shot, other techniques, and then we take certain samples based on the Lava pre-trained data set and use few of the samples, like around 50 samples, something. And then we evaluate based on how the prompt engineering, actually the few shot prompt works for the machine translation. And then we used the translation factory to generate other 7 languages apart from 8, so which is of 4.7 million rows of pre-trained data set. But the interesting detail in all this is our translation factory also made sure that each caption, you can take an example like colors, right? For example, colors. We know pink as a color in English dictionary, but in languages like French or in languages like Hindi, you actually don't have a direct word pink as a reference. But instead, they use certain words like rosé, which is the French dictionary word to describe pink. And in Hindi, it's called gulabi. So these kind of even dictionary details are ensured within our translation factory. And then another interesting detail that I want to mention before, I don't want to jump too much brief on the translation factory, but on the interesting detail is, as part of responsible and ethical AI development, we ensured that we actually found out that the Lava pre-trained dataset has this toxicity, the vulgar images, and we were able to filter based on both text analysis and the image analysis. And then we are able to filter around like 4.4 million rows of filtered dataset. And the next is we built our architecture, vision encoder with SIGLIP, which is multilingual, and the language model IR238B, very powerful model, multilingual at that time. And then we have this architecture ready. Then we went through a pre-training phase. We tested in several phases. Actually, Sara Hooker helped us a lot in mentoring this, because we didn't know what was the better way to run this. So we initially tried with 2 languages, then we went on with 4 languages, then 8 languages. But in the end, we ended up, the 8 languages one actually does so good. In the same way for the instruction tuning as well. And okay, here are the results for Maya 8B. So it's a 8B model, and the evaluation is on Lava bench file, since we use Lava architecture. And you can see the strong performance of Maya, how it shows. But another interesting detail of this evaluation is you can see there is a consistency between results across all the languages. And in our pre-training, there is actually no Bengali or Urdu. But in our instruction tuning dataset, there is Bengali and Urdu. And you can see how it even performed well in Bengali and Urdu as well. And yeah, these are some of the examples, but you can actually go to Hugging Face and try them. This is
Yeah.
our team. Yeah, thanks to the team that made this today possible.
Amazing.
Yeah, that's it.
Yeah, this is fantastic. And I'm going to have to start running a tighter ship because I think we have 6 more talks to get through and it's 5 minutes each. But I just want to say Maya for me is really incredible because it's also an example of a whole separate movement. Like now there's a next stage of Maya and the work is it's just super special to see, but also I think just the collaborations that it created is super. So huge congrats. I think this is amazing.
Thank you so much, sir.
And next we have Christopher, go for it. And yes, and now I will be very strict for time because I think we're going into the final push. So 5 minutes each.
Okay, yeah, I'm Christopher, and I'm coming from an academic perspective and also from computer science, but also from political science. And you will see that definitely some interest of mine is also in this project. I want to use this chance a bit more to reflect on our way to come together, to have this project and to collaborate. And I think also to highlight some important aspects of forming up a team and coming together. What was the important first step was that we had a lot of people bringing a broad range of interests and skills in, and not just computer science. And I think it's highly important to mention that such projects are not just for computer scientists. And here we were lucky also to have in this team a lot of expertise having social science interests or also backgrounds in. And these type of skill sets bringing just a complete new ideas and often also a different way of to think about new things and just to get new things and to find interesting questions. And as Marcia also mentioned, to find your own question, there's this KISS principle in computer science, keep it simple, and you will see that such projects often become more and more complex as you have a lot of great ideas. And to come to one research question, which is tiny enough, but still interesting to solve, it's a great challenge. It's the same as you have to write just one sentence to bring all the things in. That's the hardest part. To write 10 sentences, it's often much easier. And I was really lucky also to have the chance to bring these people here together and to have this also the chance to learn how to organize these. It's quite a challenge, and it's also about time zones. You are not just in the same time zone, and you need to find a good way to bring all the people together. Maybe once a week, or having multiple chances to meet, just to have the same picture for all and have an agenda to work on, and also to share the things we have done, to be transparent as possible, that everyone can jump in to help with a task. It was a challenge, but was something which was really important for such a project for me. As I have said, we had this general idea first that language plays an important role. And of course, it's kind of a key if you enter the world. And we had this, bringing it together to learn more, especially about the political world. And in language models, you have a lot of encoded knowledge, opinions, and so, which might hardly affect your opinion about the world, opinion about a country, for example, having a political bias, which might affect your decision. Especially if you're using large language models for decision making, it might be really critical if you just get a different advice when you're using Spanish or using German, for example. And here I would just skip this, because here the interesting part for having this team together was that we had multiple aspects to work at, and we decided at some point that some of us become experts for certain specific topics in this project, and we're also kind of co-leads in a way, taking care of their smaller things in the project, and also to track what's going on. And they were the experts, not just I, when I leaded this, or so being a captain. I mean, you need a lot of people who are feeling kind of a commitment, but also having kind of responsibility, really bringing their interests and their joy in, and also providing everyone a way to bring their joy into such a project. Is really important to stay together also for the whole time. And here I can say we are enthusiasts about the project, and we keep the spirit over the time to provide a space. And I would say we are really lucky to have the space from Madeline, from Sarah, from all the ones providing this. And you are trying to keep this nice environment and supportive environment. And here I can also say that if you have a question and you're feeling there's something, a barrier, and you need some advice, don't hesitate to ask them directly, to ask someone from the IA team about the concrete details if you don't know how to move on in this direction. They are just here also to help you with this. And I think that's the great chance also we had 1 year ago. And this brings us to the chance to work on this political bias together, and also to form and to create a publication. We are currently still working on this together. And I can say we have a lively group still. So we are meeting not weekly. Sometimes I'm currently wrapping up my PhD thesis, but it's something we still have, and it created a new network and then just new contacts, and with people from all over the world with such diverse and heterogeneous backgrounds. And that was just to have this was a great success for me. So I can just say, and enjoy the time. It's a learning, and there's also a lot of space for failure. That's part of the game. So enjoy your time, and hopefully I can see many great ideas in 6 weeks.
Yeah, that's really amazing. And also, Christopher, it's just such a pleasure having you back to present, because Christopher, I think last year when we first met, it was at the Alps school, and Marzi is actually going to this year's iteration. So I don't know if you're there again, but if you, okay. So Marzi will be there this time, but it's just really nice that it will start with us catching up and then you leading this whole collaboration. And with that, I'm going to pass on to Louise. Louise, go for it. This is a super special project, so I'm excited to hear you talk about it.
Awesome. All right, let me just skip to. All right, so we first started this problem. There was a non-for-profit called Climate Resilience in Toronto. They're looking for ways how to really push forward the agenda and help people get educated. And one of the biggest problems we had, or issues that we found, is that in Toronto, especially around Canada, there are a lot of people who don't have English as their first language. There's many people of different first languages, and for climate documentation topics, most of it is in English. So in order, how can we really bridge that gap between there? So luckily at this time, we're brainstorming, thinking of ideas. AI Expedition came out, and they're pushing forward new multilingual capabilities, and how can we use these models? So we thought this would be a great time to really go forward and test these models and how well it could work with our topics and discussions. When we first joined the group, there was only 3 of us. We joined the team. Luckily, we had some volunteers across the world. There's some that are on the call right now, but they were part globally. So when we first created this part, we joined together and were able to get local teams. Now, again, I won't really, everyone just talked about how great they were able to form the teams and some great tips. So I won't go over of how we were able to do it. But the main part of it was to address some roles and work in parallel. With only 6 weeks, we had to work fast. We had to do ideas. We had to generate. We had to do some evaluations. We had to do front end. So we worked in parallel, leading in teams of 2, thinking ideas, iterating until we finally have something that we can evaluate and present to the front end. One of the major parts is having the evaluations, which is the main aspect of our AI expedition. was that in order for this to be successful, we needed to have people with different languages. And this was great about the global context. We had experts across the globe who actually spoke the native language to be able to verify the RAGs are coming out, the information coming from the text. So we found that really, really insightful. So during the time, we were able to do successfully an implementation of using the RAG, going in there and using that architecture and sort of built that front end. So we were really excited. We were really happy what we were able to get out during the 6 weeks expeditions. So we're really too excited what happened. Sorry, before jumping into what happened, here's a little bit of background for those who are more technical. But how we were able to do this, we were storing everything into our RAG in Pinecone for those who are all our documents curated. We used multilingual re-ranking from Cohere, and we used the AI model as well as a top to get that part out. For those who are interested a bit more, I left that slides there for everyone. So where we are now, when we did those first 6 weeks, obviously the code is not productionalized, very, very sloppy code, things going on there. So during that time, when we finished the expedition, we sat back and we said, okay, how can we productionalize something like this? We grabbed our code, able to clean it up, put it in proper projects, do unit testing, get more input from more volunteers to really go in there and create these pipelines to make the code into something a little bit better that way. Next, we looked at ways how we go to our go-to-market strategy. We're actually having a donation from EY to help us look at ways to go forward and push forward this project to go to market. And we're doing our first launch coming up around May. So what's going to happen after that is we're going to go in, do our drive, adoption, reflect, and go from there. So we're really excited where we are in terms of where the project has been pushed, exactly where we've been able to go in there and clean up the code, productionalize this, make this accessible on a public-facing site. And we're really excited for the next phase. Now, how we really want for help as you is, as we go in through this testing, again, there's lots of people on this call, and we'd love for you to come help us test this multilingual chat. So here's a little beta testing. If you can just get the QR code, put your name in there, and we'd love for you to test out the chatbot, see how well it's working, and we'll continue working on our multilingual pursuits. Thank you so much.
Yeah, that's fantastic, Luis. And I love this project because it had an emphasis on building something like a UI in parallel. So I think this can be super impactful for making this usable. And now on to, so Oliver is going to talk about the IA Vision dataset, which was a dataset that was used for the recently released IA Vision. Oliver, go for it.
Yeah. Hi, everyone. My name is Oliver. I'm currently a student researcher scholar at Cohere for AI. Today, I'm excited to present our latest release, IA Vision, which is our first vision language model at Cohere for AI. It's a multimodal large language model that can understand both text and image, not just in English, but export 23 different languages. It's part of our broader research mission to make AI more inclusive, more accessible, and useful for people everywhere around the world, no matter what language you speak. So whether you speak Spanish, Arabic, or something else, you can interact with our IA Vision naturally in your own languages. So first, to build IA Vision, we start by collecting a large, diverse data set, everything from everyday real-world image to scientific charts. So apart from standard data cleaning and filtering, we also didn't just want a model that only gives short robotic answers. So we want something that feels more human, more natural, and actually useful in real-world applications. So for this purpose, we developed a recapturing distillation pipeline that takes the samples, raw data, and turn it into richer, more natural instruction tuning data. So we train the model to go beyond just giving the correct answer. It can also explain this reasoning, describe more visual details, and more importantly, engage in a more natural interactions. So next, as we highlight in our release, we didn't just stop at English. To make IA Vision truly global, we translate many of our training samples into 23 different languages. But usually, translation is just about swapping words. It's also about preserving the clarity and the tones. So we spend a lot of time refining the translations to make sure they are just as smooth and accurate as English ones. This step is especially important for languages with limited high-quality training data. And even more when it comes to multimodal data, which usually require huge human effort to collect. So by doing this, we are trying to open the door for better multilingual vision language model that work well for more people in more parts of the world. Yeah. Of course, building a great model is just half a story. So in half of the story. So in this project, we are also thinking about how to evaluate more in a real world, but also challenging environment. So it's especially across languages and visual tasks. So in this launch, we also create a IR vision benchmark, which measures the model's ability to perform practical real-world tasks, such as from describing image to interpreting charts across various languages. This helps us to measure our progress and give us a clear pictures of how our vision holds up in real-world practical use. So as a result, our IR vision achieved a strong winning rate between 25% over 50% to 79% average across different tasks and the language, meaning that in many cases, it can outperform some other existing models in 23 languages. So we also tested on a multilingual wide bench, which is an external benchmark focused on multilingual real-world visual understanding as well. There, our vision score win rate between 57% and 81%, showing our strong performance across a wide range of languages and real-world visual scenarios. So thank you so much. So now I will hand it over to my teammate, Sarah, who is going to take you behind the scene and share more about how we build our IR vision.
Hey folks, am I audible?
You are audible. Go for it, Sara.
Yeah. Thank you, Oliver. Thank you for presenting and letting us all know the secret sauce behind IR vision. But once we have collected all that great data that Oliver has worked on, we finally get to actually training the model. And yeah, I'm very excited to present how we actually trained the model and how we went about building IR vision. So can you go to the next slide, please? Yeah. So like most VLMs these days, IR vision follows the standard architecture of like a vision encoder followed by a vision language connector and a large language model backbone. One of the things that was very important to us was that IR vision be able to present or process images in of like varying resolution, so that we are able to do tasks like OCR and all, and image recognition accurately with at high resolution for high performance. And to do that, we use the strategy of dynamic image styling and resizing that helps us map an image of arbitrary resolution to the input of the vision encoder, which expects images at a fixed resolution, by tiling and resizing the images so that it's able to be processed by the vision encoder. Can we go to the next slide, please? Yeah, once it has been processed by once the image processing is done, it actually gets to the vision encoder, which is responsible for extracting semantic and dense features from these images and creating the representation that flows to the LLM. And to do that, one of the things that is extremely crucial is that we have a vision encoder that is really good at multilingual performance, entity recognition, localization, OCR, and all those sorts of tasks. And to do that, we use the recently released SIGLIP2 model. Specifically, we use the one called SO400, which uses an image resolution of 384 and a path size of 14. And that is what the image encoder is initialized from, which gives us a very strong performance out of the box for image understanding. Can we go to the next slide? Yes. Once the images have been passed through the vision encoder and the representations have been generated, it goes through something called the vision language connector, which is responsible for mapping the representation from the output space of the vision encoder to the input space of the LLM, so that the LLM can understand how the representations can be processed. And to kind of to improve computational efficiency, we use a strategy called pixel shuffle that downsamples the number of tokens by 1/4. And the vision language connector is just two simple linear layers with a speed glue activation. Can we go to the next slide? Yeah. Then we come to the LLM, which and the LLM needs to be a very strong multilingual LLM, which it actually will give us the good baseline performance. So we use IOVision 8. We use IOVision for IOVision 8B. We use Cohere Command R7B, which is further trained with the IOExpanse recipe. And for IOVision 32B, we just initialize it from IOExpanse 32B, which is a very strong multilingual model. We go to the next slide. Yes, and the training happens in two stages. In the first step is what is called an alignment step, where we keep the vision encoder and the language model frozen and just train the adapter. So it basically provides a rudimentary mapping from the output of the vision encoder to the input of the LLM, and then the major step that IOVision uses to kind of gain a lot of tasks understanding is the supervised fine tuning, where we train it in like a set of diverse tasks in 23 languages, and we train both the LLM and the vision encoder, but LLM and the connector, but we keep the vision encoder frozen. Go to the next slide, please. One of the things that we wanted was to also preserve the text-only performance of the IOVision models, and to do that, we did something called a multimodal model merging, where we simply took the LLM part of the language model and we combined it. We merged the weights linearly with the LLM generated after the vision language SFT step. What that enabled us to do is to have very strong vision language performance, and while also maintaining the text performance. Yeah, I'll wrap it very quickly, Sara. The next one. Yep. So as you can see with the steps illustrated above, we see a bump with the data that we generated, a bump with the merging, and then a bump by moving to 32B. Can we go to the next slide? Oliver has already shown you this, so I'll just skip over this one. Can we go to the next one? Yeah. So as you can see, at 32B scale, IOVision is extremely efficient and is competitive with models that are much larger than IOVision. We go to the next slide. Okay, yeah, that's all for me. Thank you very much.
Shivalika, take it away.
Okay, thank you, Sara, for explaining us about IOVision. Hi everyone, I'm Shivalika. I work as an open science research engineer at Cohere for AI, and I'll be talking about Global MMLU and Include, which are two very special projects we worked on as part of Expedition Aya last year. Coming first to Global MMLU, as part of this project, the goal was to understand and address cultural and linguistic biases in multilingual evaluation. And to do that, we kind of did a large-scale study, a cultural bias study on MMLU, which is often translated and then used a lot in multilingual evaluation. So here the goal was basically to kind of identify which questions in MMLU are culturally sensitive versus which are culturally agnostic. So we kind of did a large-scale annotation where we kind of looked at whether answering a question required cultural, regional, or dialectal knowledge. And then if a question required that, we kind of classified it as culturally sensitive. And if it didn't require that, we put it in the culturally agnostic bucket. And that's how we were able to identify culturally sensitive and agnostic subsets of MMLU. And when we did this analysis, we discovered that 28% of MMLU kind of requires cultural context to be answered correctly. And of the questions that required cultural context, we noticed that around 85% of them require models to excel at Western-centric references, which kind of prove that, MMLU requires models to, has a lot of Western bias, basically. to kind of address this, what we did was we translated MMLU, but we did used a high quality translation model, Google Translate, which significantly improved the translation quality that we ended up with. And then we further improved it by incorporating human post edits and then we kind of combined it with the cultural sensitivity annotations that we had and kind of prepared the final global MMLU data set that we had in the end. And the human post edits part is where like the iExpedition, we really worked closely with the community as part of the iExpedition to kind of improve the translation quality a lot. And yeah, that was really very, very helpful to build a high quality benchmark in the end. We also kind of did evaluation of multilingual models on global MMLU, and we noticed that we evaluated multilingual models on both the culturally sensitive subsets and agnostic subsets. And we noticed that with culturally sensitive tasks, there's a lot of variability in the model rankings across all languages and resource levels. And this kind of highlights the challenges with culturally sensitive tasks, which often require understanding of cultural, regional, and dialectal references. We've done a detailed analysis and evaluation results, which are available in the paper, so I would recommend you check that out. I also want to quickly touch upon another project that we did as part of the expedition last year, which is Include. So while global MMLU helps is useful in assessing cultural sensitivity, it still depends on translations, and we wanted to kind of truly assess regional and cultural knowledge of multilingual models. We wanted to build a in-language, truly multilingual benchmark, and that's why we kind of collaborated with the community as part of Expedition IA last year to build Include. And as part of this project, we kind of collected examinations from more than 750 sources covering 44 languages, containing both high, medium, and low resource languages. And again, we focused on collecting data sets, both academic and professional, including subjects like arts and humanities, social sciences, STEM, as well as professional exams like driver license exam, medical license exams, or bar exam. And yeah, as part of the data collection process, we did an open call as part of the community, and this was all started with the Expedition IA, where we collected the data sources, the license information, and then we kind of worked together as part of the expedition to kind of extract these exams and do a final human evaluation in the end to kind of make sure that the data has been parsed correctly. And then we build the final Include benchmark in the end. And again, we've done extensive analysis and evaluation of open source models on Include, and you can check out our paper on Include as well. And so I just want to quickly highlight that Expedition IA is like a really good opportunity to work on such large-scale projects like Include and Global MMLU. Last time it really helped us find a lot of like-minded people who were passionate about multilingual benchmarking, and also helped us find people who were proficient in lots of different languages, which was like really crucial to build such high-quality benchmarks. And it also kind of gave us a tight deadline to do such a large-scale collaboration, which requires managing lots of minute details. Like I remember with Harsha last time, like we both looked after like so many details to kind of build Include in the end. Yeah, and I'm also happy to share that it also got Include also got accepted as a spotlight at ICLR, and this was like a first time for a lot of the authors who were on the paper. So yeah, it was really special. And yeah, thank you. Over to you, Madeline.
Nice, huge.
Oh, amazing. I was just going to say, I'll let Madeline wrap us up, and she's going to share some of the details of the expedition. But I just want to say thank you to all the speakers. That was amazing. And I think it's really, hopefully it's inspired and set the tone for what we hope to achieve with this year's expedition. So Madeline, over to you. Kick us off. Tell us what's going to happen next.
Okay, I think what's really worth driving home is we know that 6 weeks is likely not enough to complete a research project. That's not the goal here. The goal here is to accelerate collaborations and to build that foundation that then you can take and run with and build off of, hopefully in the way that some of our presenters have today. We're accelerating ML research in multilingual, multimodal, and efficiency, and we're on hand to help in whatever ways we can. So my main message is it's not too late. We say that today we're wrapping up team formation, but feel free to sneak in there over the weekend. There are still teams accepting new members. You could even sneak in a new idea of your own and try to connect with new team members. Ideas like these ones from Ganit, looking at exploring a multilingual process reward model, or Karan's project here. This one seems really cool, an AI-powered scientific summarization tool. Both accepting new team members, and there's many others still too. So not too late, do join us. Get connected with researchers worldwide. We issue API credits to help you get started. But really the main takeaway is this new network of collaborators that you'll have to learn from both in the expedition and beyond. So quite quickly, if you haven't already, join us on Discord, share ideas in our sign-up sheet on Discord, get a project scope built out. If you have any questions about this process, don't hesitate to be in touch. And then, yeah, the next step is in the next few days, we're issuing API credits to start teams off, and we'll start our weekly team meetings to help you work with our powerful models like IA Vision, IA Expanse, IA 101, our command series of models, and the embeddings. And so just on Wednesday, we'll start our check-in calls for each team. You'll share updates and what's upcoming, and our research team will jump in and see how they can help set you up for success in these crucial early days of a research project.
Amazing. Okay, thank you, everyone. See you in the Discord. Let's kick off the expedition. And I'm looking forward to the update call next Wednesday and to hear from all the captains about how the projects are going. And I totally second what Madeline's saying. It's really not too late to sign up. It's not too late to express interest or to propose an idea. The Discord is really, really active right now. Everyone is jumping in. So even if you have an idea, you will probably find people who are interested in it. So, okay, amazing. Thank you, everyone. And thank you to the speakers. See you next Wednesday.